Hi, my name is Abby, I go to Schreiber High School, and I'm a rising senior. My main project is object detection with Raspberry Pi. For my third milestone, I decided to improve the accuracy of my custom melanoma detection model. I obtained a much larger dataset from Kaggle, an open source database. It contained about 3,300 images. They were already split into training and validation folders, with about 2,600 in training and 660 in validation. Like last time, I opened the Label IMG app from my terminal to annotate each malignancy or benign mole. Once the new annotations, of which there were 3,300, got saved as XML files, I ran the original Kaggle JPEG images through my JPEG conversion code like the last video. This made them compatible with TensorFlow Lite. I then zipped, uploaded, and unzipped the converted images and their respective annotations in Google Colab. After that, I followed the same steps from the last video to train a new model. I had to re-import packages like NumPy, Object Detector, and Quantization Config. Then, I trained the model in 25 epochs and 4 batches. Each of the epochs had 659 steps. The training process was accelerated by GPU, or graphics processing unit, so it only took about an hour. Once the new model was trained, I evaluated it using the 660 validation images. The average precision rate was about 62% and reached a maximum of 84%, which was much better than my last model. The model was then quantized as a tflite file called kaggleskin.tflite. It only lost about 5% of its accuracy during quantization, which was a pleasant surprise. I then exported the model to my Raspberry Pi downloads. After that, in my terminal, all I had to do was reactivate the tflite virtual environment, then change directories to the proper examples directory, and then specify that I wanted to use the Kaggle skin.tflite model by doing python detect.py model Kaggle skin.tflite. And it's identifying this as a benign mole. Now the camera quality is not great, but you can see that it does work, which is a big improvement from last time. Hi again. To analyze the machine learning model itself, I ran code to rotate all of the validation images by 90 degrees. Then I reevaluated the model in Google Colab on the rotated validation images. It didn't affect the model's accuracy much, which meant that orientation was not one of the defining characteristics in differentiating between melanoma and moles. I enjoyed playing around with rotation and exploring the traits that the model uses and doesn't use to classify each image. I did struggle a bit with efficiency. Since there were 3,300 images to annotate in Label IMG, preparing the dataset alone took multiple hours. In addition, Google Colab removes all uploaded files each time you end or reload a session. This meant that whenever I turned on my Raspberry Pi and reloaded Google Colab, I would have to re-upload all of the training and validation zip files. This also required me to rerun all of the previous code to make the files usable in Colab. Still, I was happy to get a higher accuracy from the larger dataset. My next steps just revolve around further documentation. Thank you so much for watching, and have a great day.